So, do you know what smart contracts are? They are self-executing digital contracts. Think of them as computer programs that automate actions between two parties, and no middleman needed. These contracts trigger automatically when the conditions written in their code are met. The trigger conditions can be different. For example, receiving a specific amount of money, reaching a certain date, that's a time lock, or confirmation of an external transaction. The main appeal of smart contracts is that you don't need a middleman to execute them. Parties can handle everything directly with these contracts. By the way, it's interesting that the term smart contract was first coined back in the 90s by Nick Szabo, a computer scientist and cryptographer. Back then, nobody knew about blockchain yet. Szabo defined a smart contract as a computer protocol that executes the terms of a contract automatically without the need for trust between the parties. It was Nick Szabo who tried to bring this principle into the digital world, applying it to complex operations like copyright or real estate sales. It's a pity that in those days there was no decentralized environment for their secure execution. The platform that became that missing environment was Ethereum. And here, we should mention Vitalik Buterin, who created this decentralized platform and proposed implementing smart contracts on a blockchain. In 2013, he proposed the idea for creating a blockchain protocol that would support smart contracts. The blockchain platform, through its logic and architecture, guarantees the executability, immutability, and transparency of these contracts. But they need to figure out a mechanism that executes the logic. And Vitalik came up with it, the Ethereum Virtual Machine, EVM, which you can think of as a virtual distributed processor on the blockchain. But as the technology developed, its flaws also became apparent. First and foremost is the complexity of the mechanism and the complexity of deployment, which means a high probability of errors. Next is the specific way these contracts work. Every operation in them is verified by blockchain nodes, which means high fees and slow speeds. To solve these problems, we at Cellframe designed and implemented an alternative to smart contracts: conditional transactions, which don't require running a virtual processor on the blockchain. All the execution conditions are written right into the transaction when it's created. We'll talk in more detail about how this works in one of our next videos. We also want to tell you about one of the projects within the Cellframe ecosystem. It's called QEVM, which stands for Quantum Ethereum Virtual Machine. The team behind this project combines Cellframe's quantum-resistant technologies with EVM infrastructure for deploying smart contracts. The team is building a platform where anyone can launch a familiar EVM smart contract, but with the added bonus of post-quantum protection, which Cellframe already has, and low fees. Furthermore, over time it will be possible to migrate existing ERC20 smart contracts to the QEVM network. Subscribe to our channel. Here we explain cryptic concepts in simple terms and show you how we implement them in Cellframe.